The world's deepest fish. The snailfish is one of the most recently discovered fish, being discovered in 2008 by a team of English and Japanese scientists. It is also the deepest known fish, living almost 5 miles deep. Clearly, living this deep means that certain aspects of life are very different due to the immense pressure and varying conditions. I will be focusing on the effects of living 7,000 meters deep and how the different snailfish species have adapted to this. Pseudoliparis amblistomopsis, also known as the Hadal snailfish, is a species of snailfish that is found in the hadopelagic zone, which is between 6,000 and 11,000 meters, in the tectonic trenches in the northwest Pacific. It was first discovered in 2008 around 7,000 meters deep in the Kermadec Trench. If you think this is deep, the Hadal snailfish is only the second deepest fish, with the Mariana snailfish, Pseudoliparis swirri, taking first place. It is easy to guess that the Mariana snailfish was discovered in the Mariana Trench in 2014, 8,000 meters down, which is almost 5 miles below the surface. The pressure at this depth is approximately 1,000 times the standard pressure of water that we are used to. That would be like an elephant standing on your thumb. Despite these harsh conditions, there are also many benefits to living at the bottom of the ocean. They are free from predators, and the funnel shape that occurs in deep trenches means that there is much more food available to them. Many scientists were intrigued when these snailfish were discovered, as fish are generally absent from the ocean's great depths. No fish, not even a snailfish, has been found in the bottom 25% of the ocean. This quarter covers depths ranging from 8,400 meters to 11,000 meters. The absence of fish is due to the dramatic change in hydrostatic pressure, which makes it impossible for fish to live in these extreme conditions. In order to adapt to the high pressures in the hadopelagic zone, the different species of snailfish all have the highest recorded concentrations of trimethylamine oxide, C3H9NO. TMAO is a stabilizer that counteracts the destabilization of proteins by pressure. In other words, it stabilizes proteins as pressure increases, and the concentration of TMAO is higher the deeper the fish lives. Hydrostatic pressure has large inhibitory effects on cellular structures such as proteins, making the presence of TMAO vital for survival. When looking closely at the snailfish, they display both genetic and structural adaptations, while showing great levels of pressure resistance and sensitivity. They also have antifreeze proteins in their bloodstream, which allow them to live in sub-freezing water, as deep water often gets extremely cold due to the lack of sunlight. These proteins bind to small ice crystals, thus inhibiting ice growth and preventing the recrystallization of that ice that would otherwise be fatal. To put the snailfish depths in perspective, the average scuba diver becomes incapacitated at 250 feet of depth, which is only around 76 meters deep. The reason why this happens is because the increased hydrostatic pressure allows more nitrogen and oxygen to dissolve into the blood, which can lead to nitrogen narcosis, where there is too much nitrogen being forced into the bloodstream. This results in dizziness, stupor, and eventually sleep, which is not a good idea when you're deep-sea diving. In fact, diving below 100 feet is dangerous and requires great levels of skill and training. Now that you realize how deep 7,000 meters really is, you can get a glimpse at how fascinating these fish really are. In reality, we know very little about deep-sea creatures, including the snailfish, but scientists are working every day to change this and to get a better understanding of these astonishing animals. However, it is very difficult to try and study these animals, because if you bring them up to the surface, they will decompress. This is because their cells, as I mentioned, have evolved to withstand high pressures. Therefore, when you bring it up to normal atmospheric pressure, their cells won't be able to function and would not stick together, possibly causing them to explode, rupture, or melt. They also have gas-filled swim bladders in order to maintain neutral buoyancy. When brought up to the surface, the rapid decompression would cause these swim bladders to evert through their mouths. Consequently, it is basically impossible to bring deep-sea species such as the snailfish up to the surface alive, explaining why we know so little about them. In summary, the snailfish, though it may not look like the coolest or most exciting fish, is a fascinating marvel of nature. The fact that it can live over 7,000 meters deep is astonishing, and they don't get enough recognition for what they do and how they have evolved. It wouldn't surprise me if you had never even heard of the snailfish before, but at least you know enough now to appreciate these magnificent and truly miraculous animals.